Okay, we're headed right back into it. So this is going to be part 2 of what I would say is a section box slash stair tutorial. This is something that we're going to step into together, and let's just get going. So, stairs. This is a little 3D view of our building as it is, and what I'd like to do is just kind of start with the section and what the parameters are for our section tool, stair tool itself, excuse me. So the stair itself, you probably have seen it hanging out in, where's our stair tool? Circulation, in the circulation panel. We got these handy dandy railing and stair. Railings are separate from stairs, but they all kind of come together in the middle and they meet in a wonderful family package that we can style into our building. There are a couple things that we should probably take care of before we get that stair into our drawing. So a couple things. I just want us to remember roughly where our stair is going, right? So I have nothing drawn right now for my stair. I've just got this empty box. So one thing I might want to make sure I've got is a hole for the stair, right? So I need to make sure that that stair hole is there. And where are we actually putting the stair? Where does it live inside the model? So for me, I usually like to start with a stair that's roughly 6 meters by 3 meters. So let's see if we can just do that real quick. And level 1, let's try and do this real quick here. So I got CS, let's do it in create similar here. And let's just draw ourselves a little offset. Where's my offset tool here? So offset by 3 meters or so. I'm gonna set it this way. I'll do the same thing. Do a little wall somewhere here. Give myself a little internal dimension. Make sure that these things are all tracking correctly. So you can see because my dimension tool there, my offset was taking from the center line of the wall. So I want to make sure I use the interior dimension of roughly 3,000 by, what do we say here, 4275. I probably want this to be around 6,000. We'll test this and see if it works. So in the olden days, you would have to do all these calculations by yourself on your own in an office with a calculator or by hand, whatever you prefer. And I used to literally just like sit there and say, okay, how high is the space, from one level to the next level, and divide by some number. And then you'd figure out how many risers you had, which is the kind of elevation. So up as we come up the stairs. And then you need to figure out how many treads you have. So that's how many treads in plan. So Revit automates all of these things for us. However, please be mindful of what the code says. So the code, which I have open, is definitely going to give us some hints. So if you're ever wondering, well, what is my tread and what is my riser? Remember, riser is the up and down, and tread is the kind of back and forth, so the flat part of the stair. So risers and treads. If we just pull up our code real quick here, whoops, I've just did a quick search for risers, right? So this is in 3.4.6.8. This is for part 3. So we're all doing part 3. Part 9 is only for residential. Anytime you see an assembly occupancy, I think we're assembly occupancy building, you are going to be in a part 3 type construction. Anyway, so just be mindful that there are limits here, and I just want us to keep in mind that there are limits. We've got the steps, the steps and flights shall have a run of not less than 280 and not more of 355 between successive steps. So that means that our tread must be no less than 280 millimeters and no more than 355. So generally speaking, a comfortable step is around, we'll call it 300. And you should go out and measure these things. So if you are, it sounds ridiculous, but if you're in a building that you really like the stairs, this is why we do reference cases and we have ideas. Even at Humber, you can measure how deep the tread is on a stair, and you could tell, is it calm, is it relaxed, or is it a very quick cadence down the stair? So a 280 is the minimum code, so minimum by code, and then 355 is a kind of maximum. That's a pretty deep tread. However, we also have the second sentence here. We've got we can have successive treads not less than 125. Oh, not less than 125 and not more than 180. So there we go. Shall have a rise between successive treads. I was misreading this. Shall have a rise of between successive treads not less than 125 and not more than 180. So this is again stepping up, right? So 5 inches, 125 millimeters, all the way up to 180 millimeters. So 180 millimeters up is actually a reduction from what it used to be in my memory anyways. 180, pretty high rise, but that's the highest that we can have. So a 180 by 280 tread riser is basically the maximum that we can get. So if I'm going to draw that real quick here, do something like this. This means that this dimension is 180 and this dimension is 280. So 180 up and 280 across, right? So, and I should be super clear here. 180 is the dimension in rise. It's not that diagonal. It is going to be the rise. So the riser height, 180 maximum. It can be less. It could be all the way down to 125, but we're trying to make sure people don't die in a fire, right? So that's the whole plan here, is to make sure that this code is in place so that people don't die in a fire when they're trying to get out of the building. And of course, stairs are how we go from one level to the next. Okay, cool. So why is that important when we're looking at stairs? Well, we do want to make sure that Revit has some simple systems that automatically calculate our rise over run or our riser heights while we do this. It makes it very, very, very easy. And I might argue this sense of automation, fantastic. So fantastic. So first things first, we should check our levels. So let's just jump over here to section. I'm going to start by doing a stair from level 1 up to level 2. We'll keep it real simple. Level 1 to level 2, it's going to have a slightly different elevation change, so 4,300 versus the other floors. We'll get to that though. So 4,300 is going to be our kind of overall change, right? So we need to be able to get from level 1 to level 2. That's a total of 4,300. So off the top of my head, how many risers is that if I've got, let's do this real quick. If I've got rough dimension, 4,300, and we know that our maximum riser height is, where is our maximum riser height? It is 180. What does that give us? So 180, roughly 23.888888 stairs. So roughly speaking, 24 stairs, right? So 24 stairs. So actually, is that going to be 25 stairs? 24 stairs. 24 stairs. Anyways, so we could do it this way. We could estimate 24, or we can let Revit do most of the work. So let's jump back to level 1 here. And first things first, I should probably cut a hole, right? Just going to select everything, do a little filter here, check none, grab my floor, blam. I am going to edit my boundary and I'm going to quickly draw in a hole. Now, hopefully that gave me a hole. It looks like it did. We can just double check this. If you remember, I like to use the box tool. So the box tool automatically sets up a section box around some element that you are looking at. Unfortunately, it's not ideal. Let's do this whole thing here. BX, try that again. So this is my section box. It's set it up through the whole jam here. I do want to see, my hole is actually going to be at level 1. Okay, so that's okay. Because that's what I told Revit to do, was to make it at level 1. So we could see here, good. It's pretty good. So we got a little idea of, again, I'm using my section box tool. I probably should also do one up here. So just for the sake of the continuity of the video, let's make sure that we've got, if we're going to go to level 1, from level 1 to level 2, we should probably also have that same hole. Oh, that's why it did the whole way up. My wall goes all the way up. Now I see. Kablam. We'll just make sure that goes all the way up to the roof. And now we've got that coming all the way up. So I'll just quickly cut a hole in this floor as well, edit the boundary here, and I should be able just to pick my walls. Oh, I see. That's okay. Blam, blam, and I'll just trim those. Apologies, it's hard to see the pink. Why is it so hard to see? Trim, And then trim. Where is my last wall? It's hiding on me. So hopefully this worked. Nope. Don't do any of that. Anyways, so now we have a hole. We have a hole in our slab, a hole in our slab at level 1, and a hole in our slab at level 2. And that'll just help us go from level 1 to level 2 so you can kind of see the stuff that's going on here. Anyways, let's do that real quick and let's see how we can kind of improve this. Ugh. Okay, let's cut this down. So how would we do it? So we want a stair that's going from level 1 to level 2 inside of our little stair shaft. What I'm going to jump to is jump to level 1 here. Roughly speaking, I probably want a little zone about 1500. So who knows what the minimum dimension is for the width of a stair. It should be 1100. I'm going to make mine roughly. Let's see what we got here. Let's see what we got. Let's just give myself 100 either side. Oops. Offset 100. I'm going to give myself a little bit of space here. And I'm just drawing kind of what I imagine the outline of the stair is going to be about. So somewhere in this neighborhood. And let's go ahead and see what this looks like. So if I jump into my architecture tab, we're going to jump over to stair here. You will see that we've got a couple of different styles of stairs. So immediately when we jump into this tool, you'll see that everything else on the screen goes gray. It's not unlike any of our other floor modeling tools or roof modeling tools. Oftentimes for me, what would happen is I would jump into this tool and then I would think, oh, you know, I don't want to do the stair right now. I'm just going to do the wall. You'd be like, why can't I access any of my tools? So remember that inside our modify tab, if that modify tab is green, it means you have a tool that's currently been activated. So real quick, if you're like, oh, I just need to get out of this, hit that little X, blam, goodbye. But if you are intending to build a stair, like we are, stair, and you'll see that it automatically starts with run and straight. So for most of us, all of us, I'm going to suggest we do a series of straight run stairs. Some people call this a dog leg stair. Some people call it a U stair. Some people call it a, what's the other one? Let's stick with U stair. Anyways, a couple different options here when it comes to our type selector. We've got a commercial exterior steel fire escape. We've got a residential. We got a cast in place stair. We got a precast stair. These are all kind of I think these come packaged as part of this Revit template. If you don't have these, that's okay. Just find one that works for you. It doesn't really matter which one you pick for this particular assignment. I just want us to make sure that we show some idea of what the stairs are going to look like. So if I pick my assembled stair private, this is going to be a steel stair, which is a little bit different than a concrete stair, but just in the way that it's built, like actually built, and a little bit on the Revit. But let's see what we get. So we're going to end up with a steel stair with some stringers. Stringers are the outside part, the support of the stair. We've got the treads, which are the kind of the middle part of the stair where we put our feet. The risers, the front of the stair where it meets the tread, and the railings. So a couple things here. We are going to have to set some things. So we see we've got in our constraints the base level, level 1, the top level, level 2. Pretty straightforward. What did I say? 24. I had said 24. It's telling me I need 26. The actual riser height here, it says it's 165, and the tread depth is 250. So what did we say our tread depth needed to be? Our tread depth maximum is 280. So, our tread depth minimum is 280. So you can see right off the bat, 280 is, this is not correct. So make sure that we set these up. So 280, 165 is fine. It's a little, we could probably trim this down. Let's see if 24 will work. 24 just works. So it is just under. So sometimes Revit is smarter than us, and it says the actual riser height of the stair is greater than the maximum riser height specified in the stair type. So I would also argue that 180 is a pretty tight stair. That's pretty brave. I do want to have an even number of stairs here and an even number of risers here. So this is going to be important. If I hit OK, it's going to jump me back down. Oh, it didn't do anything. It just gave me the warning. So it didn't actually force my hand. If we come in here and we could get to the edit type and see what those maximum numbers look like. Remember, the code governs. So if you're working with the OBC or the NBC, the National Building Code, or the International Building Code, the IBC, or some other building code, there are building codes all over the world. We just want to be mindful that we are following the closest codes. This is OBC 2024, so Ontario Building Code 2024. These are the numbers that come with it. 180 by 280 are the maximum, I should say the minimum potential. This is the highest rise with the least amount of tread depth. So for us, let's double check this again. I actually think we'll jump to 26 here and see what this looks like. We'll just see what it looks like. If you are curious, we can actually come in here and hit this edit type button, and we should see maximum riser height. So this is why it was giving me the warning. 180 is the true. Minimum tread depth is 280. So this is incorrect, right? So we can always double check this. Minimum run width is 1100. So we got to make sure that these are correct. There's a bunch more stuff in here. We're going to leave this alone for now. I'm going to hit OK. And now what we could do is we can start to draw in our stair. So you notice along the green bar here, we've got location line, run center. So if I drop that down, I find drawing along the center a little bit challenging, especially when we're drawing in what would be the stair core. So, real quick here, I wonder if I can do some dimensions. It's going to let me. Yeah, okay. So let's just do some quick dimensions here. 1400. It should also be 1400. So I know if I jump back to my run here, I can set this actual run width to 1400. You can also offset it from whatever location you've got. So I'm going to do 1400 for my run width. But over here, we've got exterior support left, exterior support right, run left, run center, run right. So in a conventional precast stair, you don't have those, we call them stringers. They're on the edges of the stair and they serve to support the stair itself. So it's like a little piece of steel, usually a C-channel or a custom fabricated plate steel piece that sits along the edges and supports our treads. So anyways, we're going to try this. Let's do a support left. And I got to remember this. I think it starts from the bottom and goes up, but let's see what we end up with. So base level 1 goes up to level 2. Desired number of risers 26. We'll keep it nice and generous. Tread start number 1. That's cool. Offset. So we can actually offset this a little bit if we wanted to, or we can bolt it right to the wall. So if I'm going to do exterior support left, let's try that. Let's try that real quick and let's see what we end up with. So if you notice, and actually before I do this, I'm going to zoom in. You might not be able to see it on my screen here, too much def, but I'm going to start kind of a little bit in from the wall. And if you'll see, I've got 2 risers created, 24 remaining. So what I want to do, I want to get all the way to 13. So all the way to 13, right? Why does it say? Oh, there we go. 13 and 13. Looking pretty tight. So what can we do? So we can either modify the overall dimension, the 6,000, or we can modify the tread. Oh, we can't modify the tread depth. The tread depth is set at 280. So we are in fact going to have to modify the overall size of this stair. So that's okay. So what we'll do is I'm going to keep drawing here. We'll do 13 and 13. So what I want to get to is a zone where I'm going to click once now and just, why is it giving me so, my actual run width is, it seems like it's way more than 1400. Why is that happening? I see. So the way that Revit sees this is that of course this is true. It's going to be 1400 minus our stringer dimensions. So the stringers are on the side here. So I'm going to bet that those are 50 millimeters. Let's just double check that. We got 50 and 50 probably. So 50 either side. So I actually need to make my run width. Is it going to let me? Can I change it? Actual run width 1300. Ta-da. So that's cool. And now I'm going to draw my second kind of run. So right now I've drawn 1 to 13. Now I'm going to come back to my straight run tool. And now Revit, you could see it's trying to link up. There's a kind of dashed pink line here. It's trying to link up with my previous run, which means it's going to automatically create a little stair landing, which is great. We love that. So if I jump over here, I'm going to start drawing again, and we should see, if I keep dragging all the way down here, an even match. So click once, and now I've got stairs 1 to 13 with a little automatically generated landing, and then stairs 14 to 26. So unfortunately, all right, let's delete these real quick. Unfortunately, you can see that I'm way outside of my the boundary condition of my stair core area, and it might mean that I need to kind of expand that stair core zone. So the way that stairs work, you must have a landing that it is at least as wide as the stair run. So that dimension here, the 1300, is governing how big this landing dimension needs to be. So 1300 is correct. It can be bigger, it just can't be smaller. So pretty good, except up here, this is looking like it's probably a little less than, oh my God, it's so close. Slightly less than our 1300 that we need. So that's not going to work. So what do we have to do? We got to kind of get this together, delete that, and we're going to have to get out of the stair tool and move our wall just a little bit south. Anyways, we're most of the way there. One thing I didn't talk about was the railing itself. If I jump to 3D, let's take a look at what we got. So super quick here, we could see, I can't touch any of the section boxes. So super quick though, we can see that this is what's called a metal pan concrete stair. So metal pan, this is the metal piece, and then, this is wood. That's okay. So we're not going to use a wood stair, but we'll leave this for now just for the purposes of this tutorial. And this is the stringer. So the stringer is along the edge, kind of comes all the way up. This is what's supporting our kind of tread and our riser. So same thing going the other way. If for whatever reason you drew this wrong, you could hit this flip button. We can flip it, bum, 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 like the can. And if we want to flip it, we can also, now we can start to think about what is our railing actually looking like. We can either put the railing on the treads or on the stringer. So again, this is the stringer, these are the treads. We can mount that railing element to the treads or the stringer. For me, I'm thinking, let's see what default looks like. That's probably okay. Stringer, and how are we looking? Looking good. Looking good. I wonder if I could change this whole stair. If I jump to, no, it won't let me. No. So unfortunately at this stage, I'm baked into my, I'm baked into my stair type choice. So I don't think I can go back and change it. I cannot. So that's okay. So let's go ahead and we're going to hit our little check mark button and let's see what we get. Ta-da. Well, you know what? I should save this actually. Let's do a quick save as. Bum, 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 bum. Ta-da. Okay, so roughly speaking, we've got the start of a pretty good looking stair here. What do we need to do? We need to jump back in here and make sure that some of these elements are correct. So first things first, we do need to make sure we've got at least minimum our width here. So I got to make sure this is 1300. Feels a little bit silly to change it all for that, but I do believe that that is our worst case condition all the way up the stair. It's important to make sure that that is correct. So do I have any fun? Of course not. I don't have any real doors in here. Which way does a door swing into a fire stair? Typically into it, right? So we want to make sure when people are in a panic, we want to get them out of the building. This is looking a little bit slim. This is a residential door. Let's make sure we're using something a little beefier for now. Should probably also make sure the door is at least, that's okay. One thing we haven't talked about is the actual railing itself. We probably need to give ourselves maybe a little bit more wiggle room. So why don't we do that? We'll give ourselves a little bit more space for things like the railing. So for argument's sake, I'd like to give us, why don't we give ourselves, come on, what's happening here? Let's give ourselves a little bit more space here. Let's do it. The bottoms and the top, kind of where we land here, we need to give ourselves a little bit of space for the actual extension of the handrail. So I'm going to move that down by 490 or so for now. So like I said, roughly speaking, 3,000 by 6,000, but you can see we made some adjustments here. So everybody's project's slightly different, I should say. If I jump back into my axo here, let's see what that looks like. So looking okay. We haven't done our stair extension. So at the base of our stair, we should be showing a little bit of a stair extension on the railing. But for now, this is okay. Blam. Can I just jump this into precast? I think I can. Okay, that's fine. So you can see here, I just changed it to a precast stair. Most things have remained, except you'll see we've got a slight challenge with our railing here. So I wonder if I can just pick a new host. Can I do that? Can I pick a new host? No, it's not going to let me. So we'll work on that a little bit, but you know, if I undo that, you can start to see our stair coming together a little bit. Anyways, and now, what else are we missing? Well, now my floor is gone, so I should probably bring back in that floor just a touch, and what we could do is we can edit that boundary to line up with some element in here. So let's just really quickly do this. Give ourselves a little check mark there. Nope. And now, if I was going to cut a section across here, it's going to be roughly in the right spot. And what we want to see is, you know, something like that. Oh, I should do the same thing down here. There are some other more sophisticated things that we could do, but I just want to get us started with the stair. You can see here, we probably want that to sit on the slab. What happens if I change this? Let's just change this real quick. In situ stair. Yeah, it's looking a little better. Railing's looking a little rough. You can see here we got some pre-built. How does I make it pipe? I don't think this is the code. Don't use this one. 1100 is probably the safest. We're gonna do it that way. You know what? Let's use this stair. This is probably a little safer. I could see here though now. Why is my railing in the wall? What is my railing in the wall? I'm gonna edit this real quick. I'm thinking, what happens if I move this out 50? And I'll move you up by 50. Do a little check mark again, and let's jump back to the 3D. Aha, okay, that's looking a little bit better. Technically on the left here, we don't need a guard, right? But might be able to just do, well, I don't want a pipe either. Okay. Getting a little carried away here. Anyways, for now, this is a good starting point just to get us the stair geometry. And now what happens if I want to bring it all the way up? So you should see, if we click on our little stair here, we should see is it in the edit stairs tool? Ba-ba-ba-ba-bum. Got to remind myself where this is. Aha. So there is a tool that will say, you'll see multi-story stairs here. So we could give it a shot and see if this works. I think that we might be in trouble because our floors are all different. But let's give this a shot and see what happens. So I'm going to do the same thing again, where I'm going to give ourselves a little bit of, not wiggle room, but I'm going to give ourselves a little hole where we're going to cut out on, I guess, level 3. We got to make sure we cut out our slab. And what that looks like, and select everything, filter out everything except for the floor. And now I'm going to give myself a little edit boundary here. I should be able just to blam. And then that is our hole. And if I jump back to, our 3D view, I should see a hole. So that's cool. We got our stair coming up. And now let's see if Revit is smart enough to figure out, did it give me a railing on this side? Give me a railing, but no guard. That's what we wanted. Sometimes Revit is so smart and sometimes it is so dumb. Did it give me a railing? No, it just gave me the whole guard because it's dumb. My statement remains. Not quite smart enough to figure out that we just want a railing without the guard there. Okay, so what do we want to do here? We're going to try and join our stair. So we're gonna ask it to repeat it. This works really well when the levels are the same, but because it's a shorter rise. So if we jump back to our section, we go from 4,300 to 4,100. What does that mean? It means that if I take that 180 and I say, okay, 4,100 divided by 180, we're probably going to end up with 2 less stairs. Oh, only 1.1 less stairs, fewer stairs. So let's check this out, see how this works. Let's jump back to let's do it in 3D. Touch our stair, select levels here. So what we'll do is, let's see if we can connect this next level and see if it's smart enough to do it for us. Kind of. Did it work? It looks like it's, doesn't look like it worked. It looks like it's taken the information and messed it up. So oftentimes inside of Revit, you're like, oh, I've found this really amazing tool and this doesn't look quite like what we want. So we're actually going to have to come back in and draw at level 2 to level 3. So don't do it that way. We could do it for the following 3 floors, but that first floor being different changes the way that the stair works. So let's just go back and undo that. Let's go to level 2. Where's my level 2? And we're going to see the stairs below, so don't let that kind of distract you. I feel like for now, I'm just going to hide this whole zone. Otherwise, it's going to confuse everybody. So, what's this? My floor. Oh, whoops. I probably should edit this to be aligned to the inside. Bum, 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 bum. A little check mark for me. Nope. I do not want that. That's my this is my hole. So let's make sure that's my hole. Yep, it's my hole. So where am I drawing from? I'm going to do the same thing that we did before with the stair tool. I'm going to start at level 2 and I'm going to draw a stair up to level 3. So there's going to be a small change here in that we are going to have a slight difference in only one thing, but it's the elevation of our riser height. So stair tool, exterior support left, no offset, 1,300 automatic landing. We've got a cast. I'm going to change it over here. I'm going to do cast in place stair. 25. Can I get away with 24? Nope. So it's going to make me do 25, which kind of sucks, but it's okay. We'll end up with one more riser on the left than on the right, and that's okay. So let's go blam. what do I need? Roughly even. Oh, whoops. So you can see how 14 and 11, 15, 10. So really there's a little bit less, I should say fewer treads here. So we could do 14 and 11. This is way shorter. Let's do 14 and 11. And then come over here, do the same, and we'll do the remaining. You could see here, it's up to you. It doesn't really matter if you want to have more treads on one side than the other. It's better to have them match. I can't remember if we can change it after the fact. I think we can change it now if I kind of pull this down and then I want to do another run and I'll say, 13 on one side, 12 on the other. Sure, also fine. Before we close that, I might just move. Can I do this? Can I move this up? And I see we end up with a kind of fairly large zone here for our landing. I should double check my stairs here. Something doesn't feel right. Aha! My tread depth. You bastard. Okay, there we go. So 280. Something isn't right. I want to make sure that 280 is showing as 280. So be very careful. This is the kind of stuff that Revit tries to pull. We thought we set that. We, in fact, did not. So make sure we got that 280 as our code minimum. So the code is going to govern. The last thing I want anybody from this class to do is walk out to their site and realize that their stairs are drawn or have been built to the wrong specification. So do we have what's our width here? 1300. I think that's right. And if I hit a little check mark here, we should be. Sure. And now let's check out our 3D. Okay. So looking all right. Looking all right. Now what's missing here is a little bit more of our, we need a floor slab in here, right? So we have to have the floor slab extend out. Not entirely sure how Studio is treating this, but what we can do for now is I want to align this face with this face. And a little check mark going there. And that is roughly correct. Now, I do know that this is going to mess us up when we go to connect these floors together. So let's keep an eye on that. You'll see what I'm talking about when we head up to the fourth floor here. So what I'd like to do is connect the rest of these levels. So we're going to connect levels 4 and 5 because I believe that they're all the same 4100. They are. So we can go all the way to the roof if we wanted to. So if I hit this, click on this stair and I say select levels, I should be able to connect these two. Hit check mark. Why didn't that work? I see. We got to do it one at a time. So we'll try that again. Connect level 3. Check mark. It's so goofy. Revit, of course I want to connect them all. And then connect levels 5. Check mark again. Right? So it's repeating the stair for each of these levels. So you'll see here now my, unfortunately, I'm going to have to cut out the same zone above. So how do I do that real quick? I'm just going to do, how do I want to do that? I'm actually going to copy this one. So let's do edit boundary here. Tab select. I'm going to copy this boundary. Oh, I guess I can actually just copy the floor. I don't think I have any changes here. So I'm actually going to copy the floor, copy, and I'm going to go in and go to modify paste to each level, paste the selected levels, and I want to paste it to 4 and 5, and blam. So something like this. Ta-da! So that's roughly the stairs. That's a relatively straightforward way of doing stairs. Stairs are one of the most complicated things you can learn in Revit. So I appreciate the pain of getting through it. I should mention that in this case, we really don't need the guard on the side that's facing the concrete wall. So you're welcome to delete the edges here. We do need to have a railing though, right? So I'm just realizing we do need to have a railing. So we'll have to find a family that we can use. I don't think there's one baked into this. So Railings have their own requirements in the code outside of the guard. I realize that this is called a guard. This is called a railing for some reason. It's not really a railing. This is a guard with a top cap. The railing might be inboard of this. So for our purposes, for right now, for this session, this is a good start. If I can get you guys to get this style of railing into our drawings, we'll be in good shape. So realizing I didn't paste selected levels 4 and 5. Let's do that. I don't know why I lost that. I must have undid too many things. Save real quick, and there you go. So that is our stairs for one element. Anyways, I am a little curious how we might do this a little bit differently. As I'm looking at this, I think that it's probably better for us to have a concrete stair landing. So you know what? I'm going to take back what I said. I'm not pulling this into the stair core. I'm going to edit this boundary, push us back a little bit, align that, and now I can copy this up to each level, 4100. You know what? Copy paste, Control C, and then paste to our selected levels 4 and 5. But I do, I gotta make sure we get this right. I do want to, let's do it this way. I'm gonna Control C again. I'm gonna paste to level 3. And I just wanna cut out, yeah, I know they overlap. I just wanna cut out this little portion of the stair because, oh, I see what's gonna happen. This is the wrong way to do this. But that's okay. Okay, I'm gonna undo that. X, discard the edits. Yes, it's fine. I am going to, in fact, jump to my level 3. I just want that little landing zone, and that's it. And I'm realizing that if I do it the way that I was going to do it, it was just going to show me the floor hole, and I don't want that. So check floors, and now I'm going. Oh, I have more than one floor. Great. I only want I only want this floor. Give it to me. There it is. Okay, edit that boundary. What do I want? I don't want this boundary at all. I just want this boundary in here. I'm going to trim that all together. Trim, trim, trim. Trim, trim. Make sure that it's aligned properly. And you'll notice that right now we're missing a little zone here. I do need to also provide just a little piece of stair, what's it called? Stair landing in here. Why is this here? It's gone. Hopefully that's cool. Oh, nuts. I've got two things overlapping. Oh, I see. It's probably that. It's definitely not that. Where is my hole in my loop? Is it you? Oh, it's you. There it is. Okay, so now this is a closed loop. Hit check mark. It should say cool. That's great. If we go to the 3D, we should see a little piece of, I just want to make sure our stair was looking the part. Arguably, we could also have this resting on, this concrete could rest on the slab if we wanted to keep it simple, but for now, that's what we got. I'm gonna paste this in here to selected levels. Let's give ourselves a paste on 4 and 5, and ta-da! You know, in fact, I probably also want to cut this back even further. I want this, so we can see our raised floor here. We want our raised floor only to go to the outside of the stair core here. So right now it's showing to the inside, but let's go to the outside. Yeah, that's better. Now you can see our concrete comes all the way out, and our kind of wooden elements stay outside. Cool, right? I mean, that's really it for stairs as far as I'm concerned for us. I think that if you did want to pull up some details to get some more families, there's definitely other families you can get inside of Revit if you want to go further. I think that for us, this is a pretty safe start to how stairs work. I just want us to get familiar with kind of the language around risers, treads, minimums, maximums, making sure we got our overall heights organized so that those stairs look the part. It's important to kind of get the stairs working from a code perspective because we don't want people to die in our buildings. And this is just the first. I think this is a good intro to how to build stairs inside of Revit. If you guys do have questions or comments or criticisms, we'll see each other this week. Okay. Thanks so much, guys. Talk to you soon.